Hello guys, today we'll be implementing the get-triggering method of SCR in order to verify its characteristics. So let's start. First of all, we need SCR Thyristor to start working with. Apart from that, we need other blocks as well, like we need pulse generator. Yes, and we also need ramp, ramp. We need a controlled voltage source, controlled voltage. Okay, so we need the controlled voltage source of power library. We have placed it, and to read the values we need a multimeter. We will be using a multimeter. Okay, so we also need RLC branch in order to see our output. We need Tmux, a multiplexer or mux, and we'll be needing, I think that's not enough, but no, scope. We also need a scope. Okay, so I think that's more than enough. Provide the ramp. This is similar to the voltage source, and the thyristor. Provide the anode to the thyristor, and pulse generator. Pulse generator is done. Now we need to convert this to R only. We only need resistance, and we need to measure the voltage. Okay. Now take it and place it here. And yes, that's how we can very good. Place the multimeter here, and I need Tmux. This is must click. So block B. Place it here, and now show block. Okay, and go to the properties of the scope. We need to measure 4 different values. I will be telling you later what things are we going to measure, but we need to change the layout. We need 4 ports and a column like view. Okay, so let's watch. Oh, we forgot one component, that is the bus selector. I mean the bus selector. So put it here. Now the first thing that we will be observing in an oscilloscope is the pulse that we are going to generate Okay, so take it from here to here and direct into the pulse generator. Right, now from the Tmux, now the second terminal of Tmux goes to the multiplexer, and the first terminal of the bus selector goes to the oscilloscope, the second goes to the multiplexer, and the output of the multiplexer goes as the fourth input to the scope. Now the main block that we have forgot is power GUI. The power GUI. Our circuit will not run without this. We have to change its setting to the discrete, and that's it. This is okay now. The ramp starts from 1. Okay, it is fine. Pulse generator, this time based. Okay, amplitude, we need to change the period to 2 seconds. Okay, now the voltage source, we need AC, not AC, we need DC. Okay, so 100 DC. We also need to change the measurements to voltage and apply. Put the initial voltages to 0. We don't need to change them. Okay, the thyristor, everything is okay. Now we need to change. See, we have to remove them and select them one by one and apply. We also need to change the setting of the multimeter. You will be seeing 2 different things. Okay, now close it. Okay, and I think it's pretty fine now. We need to start, but before starting I need to change the layout. Not layout, I need to change the style of my grids. The figure color, axis color. Okay, so apply the coordinates. Channel 2, channel 3. Also so I think we are pretty fine. And before starting that, go to the simulation, model configuration parameters. We need to change one parameter because we are now working with discrete system. So we need to change our solver to discrete, no continuous states, and apply. And I think we are pretty ready to go. Yes, we are fine now. See what our output tells us. The first terminal tells us about our gate, the pulse. So when the first pulse is applied, we can see that the voltage starts to increase, and in the thyristor, before the starting of the thyristor, we can see the increasing pattern of the voltage, but when the SCR is triggered, the voltage is reduced, and when the voltage is reduced, the current in the SCR from anode to cathode starts flowing fine. So that's it. I hope this will be beneficial for you. If you have any questions, you can ask me. Thank you very much.